Record this.
Pardon me?
Sir, could you record the session?
From next meeting
Yes,
on,
yes, yes.
make is everyone are attending.
Okay, okay. 1 second. Yes, that is done. Recording is also started. Okay. So
Thank you, sir.
yeah. So in regular DBMS, we have studied about the transaction processing. That time we have discussed about concurrency control. So concurrency control, typically when we talk when we have multiple transactions happening on the same content or same data. So that point of time, we have to make sure that the data remains in consistent behavior or consistent state. So we have spoken about concurrency control. We spoke about something called two-phase locking protocol and other things during that point of time. Now, in the distributed database case also, we will talk about the same thing, same concurrency control. So here concurrency control, when you say in a multi-site, multiple process operations in a distributed environment, that is quite possible. Like you have different different sites has got different data processing units, and you can have one or more number of transaction processing units also. So in such cases, when a particular transaction is going to update a data, okay, then what happens is a transactions may involve multiple SQL queries. So each query is running on different data processing units. That means in different sites, site A, site B, site C. Suppose if site A and site B has executed it and committed the operation, but site C part couldn't complete. So from the DBMS user, distributed DBMS user perspective, this is a whole transaction, single transaction. So suppose if this transaction is not successful, that means you have to roll back. But if I try to roll back, it is only the third site's commit is not happened. So only that can be rolled back. Other two is already committed, so you cannot roll back. So which will lead into an inconsistent state. Okay. So in a distributed environment, this is quite possible to happen. So we need to have a proper distributed concurrency control mechanism. Okay. So what exactly a distributed concurrency control is going to provide is the transaction processing component of a distributed database management system will ensure that all the parts of the transaction at all sites are completed before the final commit is issued to record the transaction. So from a user perspective, he doesn't know whether it is a single database or multiple database sort of things. That is what we were talking about, transparency. So from a user perspective, this particular transaction has to be committed. In that case, the transaction processing unit which has triggered this transaction will talk to all the data processing units at different sites and make sure that every parts of the transaction and all sites are completed. Okay. Now, if suppose a premature commit happens, what is the problem? This is what we discussed. There are site A, B, C, 3 sites, and the transaction is being split into multiple executions at different sites. So what happens is A and B have committed, where C has not yet committed. So suppose if the transaction fails because of some reason, maybe because of the site C's reason, then rollback at site C will happen because that is not yet committed, but cannot roll back site A and site B because already the transactions are committed. So you cannot, I mean, like what happens is the database will not be in a consistent state. Okay. That is the problem with transactions happening parallelly at different sites. So that is the need of a distributed concurrency control. So the two-phase commit protocol, what we were talking in regular transactions, here it is slightly different. Okay. So what exactly here it is going to do is the distributed database makes it possible for a transactions to access data at several sites. That means the scenario we are talking about it. In a distributed database environment, it is quite possible that a single transactions can trigger multiple SQL query executions at different sites. That is what we have seen in distributed transactions. I hope the last class, whatever we discussed about remote request, remote transaction, distributed request and distributed transactions, you will be remembering. Okay. So if that is the case, a distributed database, there is quite possible that multiple data processing units will be executing it. Final commit must not be issued until all the sites have committed their parts of the transaction. So all the sites have to be saying that we are ready to commit, and then the final commit will happen. The two-phase commit protocol requires each individual DP's transaction log entry to be written before the database fragment is actually updated. This is something to do with a mechanism called a write ahead protocol. Write ahead protocol in the sense you will write it into the log first before the actual transaction happens, and then do that. Okay. So what we do is every data processing units will write their transaction log entry before they complete it. They make sure that it can be completed, and then they update the file to the transaction processing unit that this particular transactions, all the parts are committed. So in a distributed environment, the two-phase commit protocol, what we use is called do undo redo protocol. Okay, it has three parts. A do part, which performs the operation and records the before and after values of the transaction log. Okay, that is first part. So what it does is what was the state of the database before the transaction and what is the state after the transaction. Those values are recorded in the that is recorded by the do part. Now undo part is the reverse operation. That means you have the log entry, what is the before state and what is the after state. Suppose if your transaction is not supposed to be rolled back, then looking into this log you will be able to say that okay, these database values needs to be reverted back to its old status or before status. And redo operation is if I wanted to perform this action again, then I have the log with me, what will be the status after the transaction. So it can just bring the database to that state. So three parts: do, undo, and redo. We mostly come across the first two parts in most of the cases. Redo, not a very often happening thing, but there can be some scenarios I realize that it is it's that one of the commit statement from one of the data processing units have reached late. Because of that you have asked for a undo operation, then you can perform a redo operation and complete it. But otherwise normally we will end up doing do and undo. So all these operations can, I mean, what happens if I completed the transaction and then going to write the log, if that is what I am trying to do. Suppose if the system crashes in between, that means after I perform the transaction, but before I write the log entry, if the system crashes, what happens is whatever update I have done will not be recorded into the log. To avoid such scenarios, most of the databases or operating system mechanisms uses a protocol called write ahead protocol. It's a common protocol used in many of the disk-based systems. Okay, so what it does is before performing the operations, you will make the log entry and then go for the actual operation. Now, what is the benefit of it? Simple, because you are going to be worried about the state of the data. So state of the data is changed if you say, obviously before that its log might have been written. Okay, that means whatever happens, if the system crashes at first, nothing will happen. Suppose I make my log entry, then system crashes, still the the data is not yet updated. I just have a log entry only. So when I look into compare my data, I will realize that my log entry has done a write ahead part but not performed the operation. I can still erase that entry in the log and then continue with my operation. But suppose the other way it happens, that means transaction is performed first and then I am making the entry into the log. In between system crashes, that means I have modified the database but I have not updated the log. Then what happens is somebody wanted to retrieve or somebody wanted to find out what has happened, it will be difficult, because what is the before and after state informations will not be there available. It is an updated state of the database only will be available, and you don't have a log entry also. So to avoid this, most of the disk-based systems uses a protocol called write ahead protocol. This particular protocol is what we are going to use for do, undo, and redo operation. That means the two-phase commit protocol, what we are going to talk in case of a distributed database, will use a write ahead protocol. That means before the actual transaction it performs, the data processing units will always make the log entry first. Okay. The actual I mean, in the two-phase commit protocol, what we have discussed there, it is like growing phase and shrinking phase kind of things. Like you have in growing phase, you will acquire logs, and then shrinking phase, you will release logs and other things you might have studied. Now, what exactly we do in a distributed environment is here you have a coordinator and so many subordinates. Now, when you talk about a transaction, the node in which the transaction processing unit which trigger this transaction is referred as the coordinator, and all those data processing units were going to execute some parts of the transactions are referred as subordinates. So for example, in the previous case, what we have seen, we have a transaction to be executed which affects site A, site B and site C. So the site at which the transaction processing unit, say for example site D, that is the one which is starting the transaction, that is referred as coordinator, and ABC is referred as what you call subordinates. Now in the phase 1, what happens is the coordinator will send a prepare to commit message to all the subordinates. Okay, that means you have completed the transactions, you're ready for submitting the, committing the details. So that is the message the coordinator is going to send. That means it is basically a query, are you ready to commit? So then subordinates, what it will do is, what upon receiving the message, it writes the transaction log using the write ahead protocol and send an acknowledgement saying that I am ready to commit or not prepared. Okay, so the coordinator gets back the responses from all the subordinates. Say for example, you have 3 subordinates. All of them says that yes, we are ready to commit. That information is already written into their log. They have not committed yet, but only log entry has been made. Now in the phase 2 part, the coordinator will check all these replies, and if all of them agrees, then it will broadcast a message called commit to all the subordinates. Okay, this is the actual operation. Now the actual operation is going to be performed. In the first part, it is just asked whether you have completed all your transactions, whatever I have given. They say yes, we have completed, we are ready for commit. Then I will say okay, then do commit operation. Then what happens is, already the subordinates have updated their log based on the write ahead protocol. They will now perform the commit operation. Okay, before that, what it is to be done is, it is a 2-step guaranteeing mechanism, where in the second step what it does is, when all of them receives this commit messages, they update the database using the do protocol. Okay, because in your log you have written what is the before state and what is the after state. So now the database is still in its previous state. So when I'm ready to commit, I update my database into new state, that means after state, and then I will reply saying that I have committed. That means I have performed the operations, I have committed. Okay, suppose if anyone couldn't perform, maybe some issues, he is not able to access the database or some access restrictions, some other reasons, it is not performed, then a not committed message will come back to the coordinator. So if all of them have given the commit operation, it is fine. Otherwise, if it is anyone says that I couldn't commit, that means your transactions cannot be completed because one of the part is not yet completed. In that case, the coordinator will send saying that go for an abort, that is execute the undo part of your protocol. Okay, so when all of them are ready to say, when all of them says that I'm prepared to commit, all of them says, coordinator says commit. That time the subordinates perform the do part, where they modify the status into updated status of the databases, and then they send back a message saying that committed. If they couldn't do it, not committed. If all of them says committed, this is done. Okay, but if one of them says that I couldn't commit, then this entire transaction has to abort. So what it does is, the coordinator identifies that okay, A and B have committed, A and B have completed the action, but where C has not completed. So the entire transaction has to be reverted back. It says execute the undo operation. For that, the message what it is sending is abort. So when the abort message is received by all the subordinates, they will start executing the undo operation. C doesn't have to do it because C has not been able to update your database. It couldn't complete that parts of the transaction. Whereas A and B have modified that into new state. Now the undo operation, what it will do is, it will look into the log, find out what is the before state, and then update the details into before state. So that way it is done. Okay, so for performing these undo operations, entire details are there in your database log, so you can be recovered back. I mean, you can bring back to the old state without having inconsistency in the data. You can complete this. Okay, so this is what two-phase commit protocol what we are going to use in distributed database. So the idea is simple. You are using a do undo redo protocol. The do protocol, what it does is it logs the before and after state, and undo, it can revert back to previous state by looking into this log. Redo, if any case you have to perform that operation again, look into the log file and then modify the database to the new state. Okay, and the second point what we mentioned is the entire operations are being logged using write ahead protocol. That means before performing the actual operations, you do a log entry first. So in the phase one, what it does is the coordinator asks everybody to ready to commit. If all of them says yes, it says commit. Then when the commit message is received by the subordinates, they perform the do part. That means databases are updated. Now, if anyone couldn't commit, they will be saying back that not committed. So suppose if anyone says not committed, then the coordinator informs all saying that I'm sorry, we couldn't complete it, abort. So then they perform the undo operation. All the status or state of the database goes back to before state, and then the transaction is aborted. There is no effect of the transactions happened on the database state. That's about the two-phase commit protocol what we are going to use in the distributed system. Now few topics are there which we have discussed previously also, but just saying that when you think about distributed database design, these are the 3 points what probably we have to first address. The first is about data fragmentation. Okay, so data fragmentation means how to partition the database into pieces. So whether you are keeping some tables here or some part of the table here, how exactly you are going to do it. So are you going to do horizontal splitting, horizontal fragmentations, or vertical fragmentations, or are you going to do a mixed fragmentation? So that decisions you have to do first. So that's about data fragmentation. The second part is, see, when you have a distributed database, you're having the luxury of keeping a replicate or a copy of the data in some other site also. Now, what is the advantage of it? There can be two reasons. One, I'm accessing a particular database table. Okay. Now, we have decided to keep that fragment or that table in this site because this is quite often used. Now, one more site has came up, and that site is also going to do the similar task. So they also require a copy of this table. I mean, they also needs to access. Suppose if I keep this table in site A and site B is also performing the similar operation, then every time site B has to perform an action, it has to connect through the network to access the data or update the data. So to avoid that, what we will do is we will keep the copy of the table in both A and B site. Okay, here what we do is replication. So this replication will help us in obviously accessing the data in a faster way, because the amount of time what I'm spending on the network to reach and then access it, I can avoid it. But that will bring a new challenge, because how you will make sure that copy 1 and copy 2 is the same content. So keeping consistency, you need to have synchronization mechanism. Periodically you have to do it, but that is another challenge. With, I mean, that comes with an advantage saying that data is locally available for both the parties. Okay, so data replication we have to decide. There can be a scenario. So the extreme case is no replication at all. That means every site carries independent, say distinct data. Or I can think about fully replicated mechanism. That means 100% of the data is replicated in all the sites. So all of the sites carries the same data. So that can be another scenario. So you need to give and do a trade-off between how much data needs to be replicated based on your cost, based on what kind of operations you perform, what are the tables each of those data processing units access, and sort of things. Okay, so that is the second design aspects what we have to look into it. Third one is data allocation. That means I decided to fragment it, I decided to replicate it. Now in which site, what data fragment or what replication strategy I should adopt. That is what data allocation talks about. I mean, this piece has to go into which site. This table should be replicated in which all sites. That decision making is what you have to do in data allocation. So 3 points what we have to remember when you are designing a distributed database: data fragmentation, data replication, and data allocation. Fragmentation is how to split. That is one. Second one, so you will come across vertical splitting, horizontal splitting, or mixed splitting. Then whether to replicate or not. If we have to replicate, which all fragment has to replicate. And the third one, I have replicated something, I have fragmented something, where to keep, in which site, what needs to be kept. Okay, this you will be able to do only when you have a complete understanding of the operations what is going to be performed. So each data processing unit, what kind of transactions they are going to do, which all tables they require locally. Most of the transactions are around 1 or 2 tables. Then those tables have to be kept here. These 2 tables very rarely used, so that can be kept in some remote site. This way we have to design it. So please do understand that when you start doing your project, you have to do this part very clearly. So you need to understand how many sites are there, what are the tables, where will I keep, should I go for a replication, should I go for fragmentations. These answers you have to give, these questions answers you have to give, then only you can start the project. So that we will come across. So just quickly we are mentioning what is fragmentation, breaking that single object into two or more segments of fragments. Yes, yes, someone asked me.
Sir, I'm not.
Your voice is
Sir,
breaking.
sir.
Tell me.
Data segmentation, you mentioned about vertical, the is it is
Uh,
voice is still.
your voice is breaking. I think what you have asked is what are the different types you are asking? It is vertically splitting or horizontally splitting or mixed. I mean, fragmentations can be done in 3 different ways. That is what we are coming across. In the next slide, you will see that. Is that what you are asking? Yes.
Yes, sir, kind of, sir. I
Okay. Okay. Anyway, I'll
uh,
continue with the slides
them
from
later
the,
when my net gets.
yeah, next slide. So
Yes, sir. Yes, sir. Yes, sir.
okay, now one more point I have to mention about data fragmentation is you need to know that where exactly each of these fragmentation is stored. So that is stored in a file called distributed data catalog or DDC. So this DDC is the one which is accessed by the TP, I mean transaction processing unit, as well as the data processing units for processing a user request, because transaction processing unit should know that where each of these tables are located, so that they will come to know from the distributed data catalog. So the fragmentation strategies are 3, as I said: horizontal fragmentation, vertical fragmentation, and mixed fragmentation. Horizontal fragmentation is quite simple. You have a customer table. So first 100 entries I'm keeping in one place, second 100 entries I'm keeping in another place. So basically you are dividing horizontally, row wise. These rows goes into first site, these rows goes into second site, kind of thing. The second one is vertical fragmentation. It is attribute wise. You divide column wise. Certain columns you are keeping into site 1, certain columns you are keeping in site 2. Say for example, I have a master table for employee. Some of the details like his address, his I mean like dependents who all are, whether they, what is the contact number for them, emergency contact details. Some of those things I am keeping at one place. On the other side, his previous experiences, what is his skill set, all those things I'm keeping in another place. Same table but split or vertically, column wise, and some set of attributes I'm keeping at one side, some set of attributes I'm keeping at the other side. That is vertical fragmentations. You can have a combination of horizontal and vertical sometimes. That means I cut vertically first and then decided to cut horizontally also. That means those attributes, not the all tuples are going to come in site A, rather only 100 tuples here, another 100 tuples in some other place. So I have customer table. If I say C1, C2 I break first, and then C1's half, C1.1 I'm keeping at site 1, C1.2 I'm keeping at site 2, then C2.1 another site, C2.2 another site. Like that I can do. That is called mixed fragmentation. Okay, all these are possible. You will have challenges when you fragment, obviously, or sometimes when you have to execute some data transactions, you may require to access all these, but that is the challenge what is going to happen. So now these slides you can look yourself and understand it. It is quite simple. A customer table, and then how horizontally fragmented, how vertically fragmented, and how mixed fragmentations is being done. Just go through the slides, you will be able to understand. I'm not explaining it because we have explained it multiple number of times. Okay, now the second point what we spoke about is replication. So in replication, what we do is the data is copied at multiple sites. Fragments copies can be stored at several sites to serve specific information. So I have already done fragmentations. In that I can do replications. Basically, this will enhance data availability and response time. As I said, you don't have to go to the network to get some data. Communication and total query cost, because if you are traveling through the network, you are using resources, so that cost you can reduce. Additional processing overhead will come, because when you modify a copy, you have to make sure that all the copies must be updated. Okay, so such kind of extra protocols you have to add when you have replication. And this is an example like replication. A1 you can see at two sites, site 1 and site 2. Same way A2 you can see at site 2 and site 3. This is an example of a replication. Now there are three ways replication is possible. Fully replicated database, every data you keep at every place. Then this be typically an impractical scenario, amount and overhead what you are going to come across. Partially replicated is what normally most of the distributed databases are managing, that is partially replicated database. Some of the things you will copy. And the third thing is no replication at all, only at one place. So obviously all the other advantages what we spoke for replication will now come as a disadvantage here, because if a data what we require is on a remote site, you obviously have to travel through that, so cost will increase, response time will increase. Okay, allocation is about where to allocate and where to keep this data. So again, three different ways. Centralized data allocation, entire database is stored at one site, but that we are not going to talk here because we are talking about distributed database approach. So what we do is the second or third one, partition data allocation, where database is divided into several disjoint parts and stored at several sites. So that is partitioned data allocation. Here we are not talking about replication, we only talk about fragmentation. The second one is you might have fragmented it, and certain fragments are stored at multiple sites. Same fragment is stored, a copy is stored in another place also. Copy of one or more database fragments are stored at several sites. Okay, so basically the data distribution process is the one where you will make sure that a data partition is done and data replication is done, and combination of these two have made sure that the data is spread across all the distributed database nodes in the system. Okay, this is just a comparison about client server versus distributed DBMS. Initially we spoke about distributed DBMS features, so it's just the repetition of that how exactly a client server architecture and a distributed database differs in terms of response time, resource utilizations, how exactly. So typically the client and server architecture you are familiar with, wherein clients make a request to the server executes that and then sends the data back. So entire executions happens at one place. So all the client server architecture will have a problem of single point of failure, that if the server doesn't respond, so your entire transactions will stop, all those things. Where in case of a distributed database, you will have a better option, because your data processing is already distributed. Every unit can have its own transaction processing and data processing units. So you will have an option of having fault tolerance. That means even if one of the node fails, you still will be able to manage and run the systems, not like complete shutdown in case of a client server architecture. And obviously cost wise you will have better options, because you need to have one single place, entire data needs to be stored. So your hardware and resource mechanisms what you have to put up in that one place is very high, whereas here average systems you can make a network and then they can work together to form a distributed database approach. So those are some of the differences between client server and distributed database features. This is somebody, I mean, like it's one of the person who has been involved in many distributed database, open source distributed database developments. Like MySQL cluster is mainly by this person, his contributions. So he has put up some points like these are the points. What should I look for when I'm designing a distributed databases? Okay, whatever we have till now spoke about, he just put together as certain points so that this can be the benchmarks you have to use to start off designing when you are designing a new distributed database. This much is that what we have to discuss for distributed database concepts. So theory concepts we have discussed completely. Okay. Okay. I mean, ma'am has already informed you about the quiz. So tomorrow at 8:45 you have quiz through AUMS. It will be purely MCQ and slide number 1 to 22. Whatever the slide shared up to 22 slide number is what the content for the quiz. Okay. So be prepared with the content and then come. Okay, then these slides will be shared to you. Okay. Session is done, so you can leave. Thank you.
Excuse me, sir.
Yes.
Thank you, sir.
Since
Yes.
tomorrow, it's only this PPT till slide number 22 and the previous RDBMS part is not included, right?
No, only the slides what is shared, only from that 1 to 22. That's it.
Okay, sir.
Yeah.
Thank you, sir.
Thank you.